Hey guys, welcome back to the garage. Hey, there's been a lot of chatter lately on the Centroid CNC forums about encoders. And one of them was about the Omron encoders that are available on eBay. They're sub $30 basically. So they're pretty inexpensive. So the question is, are they really Omron encoders or are they just knockoffs? So I decided to take the liberty to go ahead and order one to do some testing. I ordered it. It's been about 2 weeks ago. So the e-packet delivery option sure speeds up getting things from overseas here to the States. So I've already taken it out of the yellow Chinese tape job. And here it is right here on the bench. So you can see at first glance, it looks like it came in an Omron box. I flip it over, there's a bunch of Chinese writing on the back of it. I haven't opened it up yet. The model number on this is an E6B2-CWZ1X. It's 5 volts, 2000 pulses per revolution. It is a line driver differential encoder. So that's what is specified by Centroid to use on their motion controllers. So let me get you turned around and we'll take it out of the box and see what we got. There's the model number. This is the correct model number no matter where you look, whether it's eBay or Mauser or DigiKey or whatever. You'll find on Mauser and DigiKey this thing's really expensive. Obviously Omron Corporation, made in China. Okay, there was some writing on here, 847469. I'm not sure what that was all about, but let's go ahead and unbox it, see what we got. Oh, a little plastic coupler there. Looks like it's meant to be like some press fit. And here's the encoder. There's the encoder, a little plastic coupler. Omron in Chinese. We've got a rotary encoder sheet, instruction sheet. It's in Chinese on one side. Looks like we got English on this side, and that's it. Gives an output circuit diagram. Okay, CWZ1X. So here's the one that pertains to us here. We'll just go by what's on the barrel of the encoder. Okay, let's take a look at the encoder itself. There's the part number. Brown is 5 volts, blue is 0 volts, shield is ground, black is output A, white is output, orange is output Z, and then the inverse, black and red is output A, white and red output B, orange and red output Z. So it looks right. I'm not going to take this thing apart. I'll go ahead and undo it and we'll measure it and see how much wire comes with it. Looks like we got just a little over 6 foot, so it's what, that 2 meters or so. So it comes with a nice long piece of wire. And let's take a look at the shaft size. 6mm shaft. It's got a 6mm shaft. Okay, what I have here is the schematic that I'll be using in my Acorn demo series. What's important here is this P10 schematic. It gives us the pin numbers and a description. Over here, pin 9 is 5 volts DC, pin 8 is B, pin 7 is A, pin 6 is Z, pin 5 is B inverted, pin 4 is A inverted, pin 3 is Z inverted, pin 2 is common, there's no connection to pin 1. So we'll be using this to hook up the connector. Now what I'll be using is this connector. It's kind of a breakout board, but it actually has a hood. You can buy these from Adafruit. Okay, there's the barcode label. It's http://Adafruit, ADAFRU.IT/3123 is the part number. Get it out of the packaging here. Okay, it's a male connector. And it pops open on the side. And it folds open and it reveals a DB9 breakout terminal block, and all the pins are numbered here. Okay, the kit comes with this little strain relief that clamps right here. The compartment's a little bit tight, so let's estimate cable length real quick. That should be plenty long enough. I'm going to cut these into my trash bucket. If you guys haven't seen these Klein screwdrivers are really nice. There's the part number 32581. It's got really nice tips. It's got a small Phillips on one end and a standard on another. Then you can flip this around and you've even got a much finer tip on the other end. So I find these pretty handy, especially for small terminals like this. Amazon sells these. I've actually bought 2 of them just because I know I always leave them laying around. So the part number again is 32581, and it's from Klein Tools. And we'll take this out. Okay, this says ground on this side. When you're making up an encoder cable, only shield the connector side. Don't shield the encoder side. So let's get this tightened up. And we'll nip it. You know, ultimately, if this is going to be permanent, you would want to tin the ends of these wires with solder. But this is just for testing, and I may be doing something different. I might be shortening the leads, so I'm not going to bother too much with that. Okay, that's good. See, the next wire is 6 here, and 6 is Z. Looking at our encoder here, Z is orange, so wow, isn't that interesting? Well, looks like here's one already. I don't see an orange in this bunch. It's supposed to be orange, and I don't see an orange. So you know what? We'll just continue. Well, let's count the wires, see what we got here first. 1, 2, 3, 4, 5, 6, 7, 8. Very interesting. So they say there's an orange. The encoder says orange is output Z. There's no orange here. So here you go. Chinese stuff. Here's the Chinese paperwork. Orange output Z. Orange with the red output Z. You can tell this is a really crappy Chinese knockoff because the wires do not seem to correspond with the encoder. Look at the barrel here. Brown, 5 volts, blue is common. Okay, so here's blue. Blue and brown. Okay, I've got them pulled back. All right. So I think what we got here is there's no mention here of yellow, and there are yellow wires here. So instead of orange, I think they used yellow. All right, so here's our black with a red. And black is our A. So this is our A. This is our channel A pair. Then the next one is white and white and red. That's white and orange, not white and red. And here's white. And then we've got yellow wires. So there's a yellow with the red and yellow, not even close. That's actually a yellow with orange, but this is yellow. So it's not orange, fellas. It's yellow. It says, yeah, should have been an orange. Orange with the red. We do have a white, and we have a white with a red. We have a black. We have a black with a red. And then over here we got blue. We got brown and blue. So not orange. They're yellow. So let's continue on with hooking this thing up. All right. So looking at the Centroid diagram, we're looking for pin number 6. Pin number 6 is Z. And according to this, it's orange, which is yellow. So we're looking for a solid yellow in this mess. Make sure, okay, there's our tracer. Here's our solid. Slip right in. Okay, and not Z is pin 3. I'm following the schematic here. So not Z is pin 3. We did Z. So let's do not Z, pin 3. I'm kind of with the rest of the world. The thing I hate the most about this stuff is having to deal with connectorizing stuff. Okay, that's in. All right, pin 7, according to the schematic here. Pin 7 is A, and our A is black. So we want to make sure we get the black wire. Here it is. Okay, I jumped right in. Okay. Our not A is pin 4, and not A is black and red. That's this one. Okay, so not A. Okay, not A was pin 4, and we have it in pin 4. So over here we're on 8. Pin 8 is B, and white is output B, and then white with the red is not B. So we're looking for white, solid white. Here it is right here. I'm trimming these back a little bit. They're small enough they'd probably be able to tuck them in that connector all right. Got that one in okay. Snug it down. Okay, pin 8 is B. Now we want pin 5, not B. Double check. White and the red is not B. And that's this one here. Okay. Okay, we just did pin 2. Wait a minute. This is why we got to do this twice. Okay. I did that wrong. Let's take that out. This is pin 2. We'll double check everything. So this is, we want not B. and not B is in pin 5. And that's right over here. Okay. Again, not B is pin 5. And that's what we got. Almost put it in common. All right, so the next one here on this one is pin number 9. And pin number 9 is 5 volts DC. 5 volts DC is brown. Give it a tug, that's good. And then our last one would be common. So pin 2 is common. Common is blue. And that's what we got left, blue. And now common goes to pin 2. And there's no connection to pin 1. So let's double check our work. Okay, pin 1. No connection. We have no connection on pin 1. This is pin 1. Pin 2 is blue. Pin 2 is common. And blue is common in the encoder. Pin 3 is not Z. Not Z is our yellow with the red. Let's see if I can see. Yeah, there's our tracer wire right there. That's our not Z in pin 3. Pin 4. Pin 4 is not A. And not A is black with the red. And here you can see, hopefully, this is our black with the red. And pin 5 is white. Pin 5. Pin 5 here is not B. And not B is white with a red. And that's white with a red right there. And then pin number 6 is Z. Of course, this is all messed up. It's yellow. And this is our yellow, and that's in pin 6. Pin 7. Pin 7 is A. And here's black, and here's our black. And then pin 8 is B, it's white. There's pin 8, it's white. Pin 8 is B, double checking here. Here's B is white. And then number 9 is our 5 volts. 5 volts here is brown, this is brown. So it looks like we've got it all put together correctly. All right, so let's see if we can assemble this, the strain relief, so we don't pull on a wire when we're doing our testing here. Kind of tuck these wires into the case so they don't get pinched. There we go. Not sure how well I like this connector because it doesn't offer a lot of clamping for the strain relief, but it looks like it'll work. All right, see the screws are Phillips, so I'm going to swap my screwdriver to the larger Phillips. See if we can get it in there. Try and get these screws started straight. Make sure we're not pinching any wires. Looks good. Could use a little bit bigger Phillips. I'm going to flip this around to the straight blade. Oops. Yeah, it fits good. All right, make sure we got nothing pinched here. Double check, make sure all our wires look good. They look good. Zoom in here for a closer look. That looks good. And we'll close it up. Now, the one thing about this Adafruit connector is typically the male has thumb screws on it. And there are other vendors that actually has thumb screws. In this one, these are threaded, so there's no real way. See, these are little standoffs that come with it. So this isn't really going to work. It'll work for testing purposes. I've got an Acorn right here. There's the connector. There's Acorn's connector, and here's our Adafruit connector. So we basically we can plug it right in, and it does engage well. So for testing purposes, it's going to be all right. Let me get my Acorn wired up, and we'll test it out and see if the encoder works.